Hello guys, today I want to clarify a topic related to completing square or what is known complete square. And I'll show you several ways, so actually here in this video I'll highlight two ways how to do it in a very fast manner and efficiently. So first of all, let's try to define complete the square, what it means, what is hidden under this term. So simply it's a binomial expression which is squared. So basically it's binomial of power 2. Okay, if those words don't tell you about anything, so you can simply remember that this is actually when you have two, let's say, numbers, or instead of a and b there might be actually variables, and if you add them or subtract and you square it up, so you consider square of the sum or of the difference, so you'll actually have an expanded form, a squared plus minus 2ab and plus b squared. Okay, I'll prove that in a few seconds, but actually the primary goal is to come up from expanded expression into expression that contains expression in brackets, which is squared. So what is known a complete square? So this is what is known a complete square. So typically where we can meet such questions or problems related to complete square. So first of all, it's simply, let's say you have an expression like x squared plus 3x plus 2, and you need to make the form where you have a complete square. So something in the brackets, and in this case you are asked to have all x's collected in those brackets and squared up. So simply to say that you want to have x plus, or probably minus, some number which is squared, and then the rest part, that's also another number. So simply this sort of problem, that's the first type of problems or questions. Let's say type of questions where you ask to come from expanded form into a bit shorter form which contains complete square. Actually all x's collected in one expression which is squared. Alright, that also might be the second type of questions related to the functions and mostly to quadratic functions. Quadratic functions or expressions, and mostly functions. So what sort of questions might be here? So typically you have a quadratic expression, let's say the same, we can take the previous quadratic expression and now we set up a function. That's definitely parabola or quadratic function. And you need to come to the vertex form, which also contains a complete square. That's sort of x minus h squared plus k, where h and k simply coordinates of the vertex. H, k simply coordinates of the vertex. Let's just remember briefly. So this is, let's say, parabola with leading coefficient a more than 0, and you have the vertex point of that parabola which has h and k as the coordinates. So, and complete square will help you immediately to define those coordinates. That's the second type of questions where you might meet complete square and need to know or need to apply the methods that can lead you from this expression, which is expanded one, into expression containing complete square. Okay, so trust me, it's all based on this formula, this single formula. If you know where it comes from, so you can skip the proofs. Right now I'm going to show you why a plus minus b squared is actually this expanded form. It's simply we need to do is to multiply this expression by itself. So that's why I'll show you two ways. I'll show you right now the proof for a plus b squared equals to expanded form, And this is the first type when we have a plus sign. So we simply add in a and b. This is binomial of the power 2, if you remember binomial series, and you know something about binomial expansion. Okay, so what is that by definition? So we take an expression and raise to the power of 2. So it means that we need to multiply this expression by itself. Okay, and now let's do simple expansion. So a times a and a times b, and b times a and b times b. So finally we'll have the form a squared, then ab, then ba, which is actually ab as well, and b times b, which is b squared. So those a and b together will give you 2ab, and that's how we arrive to the right side of that. Okay, so we proved. So with the minus, we'll do the same. However, expression now literally is the difference. So now we're taking the difference and multiplying by itself. Okay, let's do the same expansion. We'll have a squared minus ab minus ba, which is ab also, and minus times minus b will give you positive b squared. So that will give you negative 2ab, and you have actually the same formula, but instead of plus, you're taking the minus sign. Okay, so we proved that. So consider that we proved. Why is it so? And now let's go to the complete square. As I said, it's based on the formula a plus minus b squared equals to a squared plus minus 2ab and plus b squared. How we are going to use that? So we have first expansion, and now we need to go back to the contracted form, or what is known complete square. So I'll show you on some examples, and I'll demonstrate two ways. The first way is to try to recognize this formula somehow by changing the middle term. All right, let's say we have an expression x squared plus 3x plus 2, where we've got it from here, the first type of questions, and we want to arrive to something like that containing complete square. So literally to say, we need to arrive to something plus or minus x in the brackets, which is squared, and probably plus or minus another number. So we're looking for this form. Okay, hopefully you understand that in this case you need to compare with this expression, because we have the middle term, which is here, and it's positive, so we're taking positive sign. So we will use the formula a plus b squared equals to a squared plus 2ab and plus b squared. Now what we're going to do, we just need to compare term by term. Let's say a squared is simply x squared, so we figure out that a is x. We also have 2ab, which is equal to 3x, in order to apply the formula. But unfortunately, we don't have that, because instead of 2ab, even if you plug a equals x, so right now we have 3x, but you want to have 2ab, so 2 times x and times unknown b. So what we're going to do, we just need to rewrite this middle term as the following. So I write 2 because we need to have 2 anyway. Then I write x, which is simply a. That's why I'll put instead of a my x, and the rest part should sum b. But this whole construction, or this whole structure, should be equal to 3x. How from 2x times b we can get to 3x? So there are two ways. We can simply put 2xb equals 3x, and from here we can figure out that b is simply 3 over 2 because x will be cancelled, or just compare coefficient before x terms in both equations or in both expressions. So b is 3 over 2. So that's why instead of b, we need to write 3 over 2. And indeed, you can check yourself. If you 2 multiplies by 3 over 2, 2 will be cancelled, and you will stay with 3x as you're supposed to have. Okay, so because we found that b is 3 over 2, we just simply need to have this term. Don't care about what you have here. You just need to have this term squared. So that's why, with no relation to what you have here, you add 3 over 2 squared and immediately subtract it, because you don't want to change your original expression. You understand that this expression, this small part of the expression 3 over 2 squared minus 3 over 2 squared will give you 0. So that means you didn't change anything at all. And look what we've got. And so, okay, and the last part, we need to add 2 finally, because we have 2 in order to have this equation or this expression equal to the whole that. All right, let's move next. So what we have, this part, according to the formula, a complete square. So we simply have the following: x plus 3 over 2 completely squared. So that's how we get this part. We just apply the formula a plus b squared. So we shrink this part. So I put the yellow marker here in order to say that this part is already x plus 3 over 2 squared. Okay, let's move next. So we have still negative 3 over 2 squared, and let's rise up power 2. It's going to be 9 over 4 and plus 2. Okay, so one more time, from expression that we had originally from here, x squared plus 3x plus 2, we arrived to x plus 3 over 2 squared that we are supposed to do, and the rest part, which is negative 9 over 4 plus 2. Of course, we need to simplify it. And finally, I'll rewrite that. It will be equal to x plus 3 over 2 squared. And then I simplify, simply it will be negative 1 over 4. Okay. So that's why if we compare, for example, you'll be asked what exactly will be in the brackets. So we have the answer. It will be x plus 3 over 2. What will be outside the brackets? Just some number, negative 1 over 4. Okay, so what possible application? So at this stage, you can even factorize if you like, because here you can apply the formula. Just remember, a squared minus b squared. So you have a complete square containing x, and you have the rest part 1 over 4 that you can make up easily into b squared. So how to factorize, for example, one possible application. First application in first of factorizing. So what you can do, you can apply this formula, which is simply a minus b and a plus b. So in your case, 1 over 4 is b squared, so b is simply 1 over 2. So we can, instead of 1 over 4, we can have the following. It's going to be 1 over 2 squared. Now you have a difference of 2 squares. And apply this, so you can factorize. So second application. Application for the vertex form. Alright, so I just move back and say that instead of 1 over 2 squared, we originally had 1 over 4, which is negative. Alright, so application for the vertex form. Remember, vertex form, let's say this was originally function, y from x. So we can say that this expression is simply y from x function. What we can do, now we know that y from x has a complete square form as x plus 3 over 2 squared minus 1 over 4. So we have that. How to get the vertex form? This is already the vertex form. So just match with the pattern that you have in terms of vertex form. X minus h squared plus k. If you compare what you have in the brackets, you have minus h and it should be equal to 3 over 2. But because you have minus, so minus h, you can rewrite as x plus minus h and everything squared and plus k. So it looks like negative h is simply 3 over 2. So we can figure out that h is negative 3 over 2. And this is x coordinate of the vertex. And k is negative 1 over 4. So you can put negative 1 over 4 into k. And that will give you automatically, it will automatically give you the coordinates of the vertex. So vertex will have negative 3 over 2 and negative 1 over 4 as the coordinates. So you see how, like, what sort of possible application you might meet. And this is in a full correspondence with the words I started from. So type of questions. So basically have a complete square form, just simply from expanded, give the shorter way of right-hands and quadratic functions. That's the vertex form application. So I told you that there are two ways, but at this stage I simply stop the video, pause it, and in the next video I'll tell you about the second way, how we can do that. Hope you enjoy. So of course this is about practice, and simply to say you need to have more and more practice here. So let's try to apply the first method. Let's have a little practice and let's try to apply the method that I recently showed you into the following. Let's say we have to factorize the following expression. We have x squared plus x and plus 6. Now it's better to say minus x and minus 6. Okay, we want to have a complete square for that. So let it be, this is an expression, so we have to have, we need to obtain the following structure. X plus or minus something squared and plus or minus some number. Instead of number, I just put some m and n letters, denoting that we have some numbers instead. So basically m, n numbers. There might be integers, there might be real numbers, no matter. Okay, so let's apply our approach. Because we have the minus before a middle term, I will use the following formula. A minus b squared equals to a squared minus 2ab and plus b squared. Okay, so now I'll just write down what we have originally. So obviously a is x squared. And here we have the following. We have minus x. We have minus x. But we want to have negative 2 times. Instead of a, we have x. So that's why I'm writing the formula 2. Instead of a, we have x. And something left for b. But in order to finally, after multiplying by some number, I'll get finally negative x. What I should have here? Simply 1 over 2. Because I know that 2 and 2 in the bottom will be cancelled, and I'll stay finally with negative x here. So that's why, according to the formula, b is 1 over 2. I can write it here, so let's mark a is x, so b is 1 over 2. And simply what I need to have b squared. So remember, I don't care about what I have here. I just simply add b squared. So b squared is 1 over 4, right? Because 1 over 2 squared. And I immediately subtract 1 over 4 in order to have this 0. And then finally I subtract 6 because I had it originally. Okay, so I highlight a complete square according to the formula. It's here, up to 1/4. It's right there. And then I have the rest part, -1/4 and -6. Now I'm just going to simplify that. So this, according to the formula, will give us x minus 1/2 completely squared. That's complete square. And the rest part will give me -1/4 and -6, which is simply, if I turn it into one single fraction, I'll get -25/4. -25/4. Okay, so I've got the structure, and according to what I'm supposed to have, and I can even compare and figure out which numbers actually stay there. So for m, it would take the form x plus m squared, let's say plus n. I will have the form if I compare with what I have in my numbers. So m is -1/2 and n is -25/4. Alright, so you can even first factorize if you need that. For example, through a complete square, try to factorize. Alright, let's do it. I simply apply the formula, which is a squared minus b squared. And I know that a is x minus 1/2. So I'll get simply have x minus 1/2 squared. And minus, and b squared is 25/4. So I can write as just numbers which I later square up. So instead of b, I simply have this 5/2 squared. And now what I can do, I can use the formula. It's equivalent to a minus b times a plus b. And what I can do, I can simply get x minus 1/2 minus 5/2. That's the first bracket, a minus b. And then simply I'll get times x minus 1/2 and plus 5/2. From where you know that if the total expression is 0, you can put 0 instead of each factor and solve. So you see how many possible applications of completing square. So I show you, that was shown for quadratic expression, how to apply a complete square and how to arrive to your goals. For example, how to find coefficients, how to factorize. We've done it recently. And finally, how to solve. Thank you guys. Hope you enjoyed. The second way will be in the next video. Goodbye.